All right, guys, I have an absolutely rubbish drawing of planet Earth and the Earth's atmosphere up here. And what we're going to do is a quick rundown on ozone. Now, just to review, ozone is O3. Now, it is a radical and unstable molecule, so it's 3 oxygen molecules. Now, that's all well and good, but where is it, right, and what does it do? So let's talk about stratospheric ozone first. Stratospheric ozone lives in the stratosphere. So let me go through this real quick. We got planet Earth, the troposphere, that's where you get all tornadoes and hurricanes and all that kind of good stuff. And then you're going to get the stratosphere. Just as you get into the stratosphere, there's a layer of this O3 floating around, this ozone, stratospheric ozone floating around. And the reason that's important is because the sun is giving us UV light. So you notice it's got an angry face. That's very, very intense UV light. And it's actually more intense than what life here on Earth evolved to deal with. So the ozone layer's been there for millennia. It wasn't like a new concept, right? So all these plants and animals evolved with a certain level of radiation not being there because of stratospheric ozone. Let's say that again. All these plants and animals evolved with a reduced amount of UV radiation from the sun because of stratospheric ozone. Okay? And so this ozone floating up here is good. And what's good about it is that it essentially sacrifices itself to block UV radiation. So it doesn't block in the sense of like a mirror. It doesn't like reflect it or block like, I'm strong. Something like that. You got 3 molecules, right? And that's an unstable molecule. UV light, this is wavelength. That's what my little worm thing is here. So this is, imagine this is an O3 molecule, and this is angry UV light coming from the sun. It comes down, breaks it apart into 2 and 1. So that energy was used in that breaking process, and then because it's this free radical oxygen and O2 immediately reforms to make O3. So it breaks and then reforms, and the energy that was taken to do that has been absorbed and for nothing, right? So that UV light gets absorbed by that molecule, the molecule breaks apart, comes back together, and that UV radiation never makes it to the Earth. This is the mesosphere, no one cares. This is the thermosphere, nobody really cares about that either. Now, down here, we can get ground level ozone. Ground level ozone is bad. So, when we talk about ground level ozone, let's talk about where it comes from. It is mostly associated with the transportation sector, with exhaust from cars, trucks, that sort of thing, planes, all sorts of stuff. Anything that's burning, internal combustion engines. It can lead to PANs, which is photochemical smog. So PANs are peroxyethyl nitrates, and that's photochemical smog. That's the smog that you would see in LA, New Delhi, places like that, even big cities like here in the city of Dallas. We have summer ozone alert days, and that'll be on your news, it'll come on your phone, and on those days it's hard to breathe, you'll cough a lot, there's lung irritation, it exacerbates symptoms of, say, asthma and other breathing conditions. And all of that happens right down here on the surface of the Earth because of the transportation sector. That's bad. So at some point you're going to see a question on the AP exam, and you're trying to make a decision of whether or not the ozone in that question is good or ozone in that question is bad. Stratospheric ozone is good. Ground level ozone is bad. Stratospheric ozone absorbs that UV light and keeps it from damaging the plants and animals on Earth. Ground level ozone does damage the plants and animals on Earth. It makes breathing more difficult. It slows down the rate of photosynthesis. It damages the plants, and et cetera, et cetera. And it leads to photochemical smog. So there's several different issues going here, but the main thing you need to know, it's good up here, bad down here.